Hello everyone, welcome back. In today's session, we are going to learn how to interface a 16 by 2 LCD with PIC16F877A using 8-bit mode. This is a very important topic because LCD is one of the most commonly used output devices in embedded system. In this video, we will cover LCD basics, 8-bit mode concept, pin configuration, hardware connection, important commands, and complete embedded C program. So let's start. Now tell me, what is an LCD? An LCD or liquid crystal display is a device used in embedded system to display text, numbers, and system status. The LCD we are using is 16 by 2 LCD. The 16 by 2 LCD means there are 16 characters per row and the number of rows are 2. So, in total, we can display 32 characters. Now, let's see what are the advantages of LCD. They are low power consumption, easy to interface, and very useful for real-time display. That's why LCD is used in digital clocks, measurement systems, and embedded control panels. Now let us see how to interface a 16 by 2 LCD with microcontroller. When you connect an LCD like 16 by 2 to microcontroller, you need to send data. This data is sent through the data pins. In the picture, you can see the pins from D0 to D7. They are the data pins of the LCD. So, if the microcontroller wants to transfer the data, the microcontroller should send the data to the data pins or the data lines. For transferring data, LCD supports two interface mode. They are 4-bit mode and 8-bit mode based on how many data lines are used for communication. In this video, we will be discussing about 8-bit mode. In 8-bit mode, all the data lines from D0 to D7 are used to receive data from microcontroller. This means that one full byte is sent at once, which makes the communication faster. This is the advantage of 8-bit mode, that is, it makes the communication or the data transferring faster. What is the disadvantage of 8-bit mode? Yes, the disadvantage is that it uses more input-output pins. So, we trade pins for speed. Now let's check the LCD pinout and control signals. LCD has three types of pins. They are power pins, control pins, and data pins. The power pins are VSS, which is always connected to ground, VDD, which is always connected to plus 5 volt or positive voltage, VEE, which is used for contrast. And the control pins are RS, which is register select, RW, read or write pin, EN, enable pin. Now let's check the logic of control pins. When RS is 0 or register select is 0, it will work in command mode. When RS is 1 or register select is 1, it will work in data mode. When RW is 0, the data is returned to LCD. And when RW is 1, the data is read from LCD. Now, the next pin is EN or enable. It is very important pin. It works like a submit button. LCD only executes when EN pulse is given. The next pins are data pins. The data pins are D0 to D7. It is used to send data or commands. Now let us see how to connect PIC16F877A to LCD. The data lines of LCD, that is D0 to D7, are connected to RB0 to RB7 of port B in PIC16F877A. And the control pins, that is RS, RW, and EN of LCD, are connected to RC0, RC1, and RC2 of port B respectively. So, you have to configure TRIS B and TRIS C as output. If you don't configure it as an output, the LCD won't work properly. Next, the power pins, that is VDD, is connected to 5 volt, VSS is connected to GND, and the contrast pin VEE is connected to 10 kilo port. Now let us discuss the main commands used in LCD. So they are 0x30, which is used to set the mode of the LCD as 8-bit. And it is also used to set the number of lines and the size of or the font size of the LCD. Next one is 0x0C, which is used to on the display and of the cursor. 0x06 is cursor auto increment mode, which moves the cursor right after each character. And the next command is 0x01, which is clear display command, which clears the screen completely and the cursor goes to home position, that is 00. Next two commands are used to select the position of the text. 0x80 is used to select first row and first column, and 0xC0 is used to select second row and first column. Now the method or the sequence to initialize this code is, first you have to give 0x38, then 0x0C, then 0x06, and at last 0x01. So these four are the codes that is used to initialize LCD. Okay. Now let us see the programming part of LCD. In the first part is my pin mapping. Here you can see some lines like hash define RS space RC0, hash define RW space RC1, etc. These lines are used to assign meaningful names to the microcontroller pins and ports. Instead of using actual hardware names like RC0, RC1, RC2, and port B, we give the functional names based on their purpose. And the next part is command function. This is used to send a command to LCD. First, the command value is placed on the data port so that LCD receive it. Then the control signals are set such that LCD understand the incoming value as command, and it needs to be written into the LCD. And the enable pin is activated to notify the LCD that data is read and small delay is provided to allow proper processing. Then enable pin is deactivated, which completes the operation and ensures that command is successfully accepted by the LCD. And next is the data function. Here also you can see that the data function is used to send data to LCD. Okay, first the data value is placed on the data port so that the LCD receive it. Then the control signals are set such that the LCD understand that incoming value is data and it needs to be written. Then the enable pin is activated and notify the LCD that the data is read and small delay is provided. Here you can see delay millisecond, right? 2 millisecond. And this allows proper processing. Then the enable pin is deactivated, which completes the operation and ensures that the data is successfully accepted by LCD. And the next function is to initialize the LCD. To initialize the LCD, we have to give these four commands, that is LCD underscore CMD 0x38. That is, this is a function when it calls LCD underscore CMD 0x38. This 0x38 will be transferred to the function name void LCD CMD. Okay, so a CMD will receive 0x38 and then that 0x38 will be transferred to the LCD. In the same way, when the function LCD CMD 0x0C is called, 0x0C will be transferred to the function and then it will be sent to the LCD. So next, how to show the data or how the data is transferred. Here you can see the command lcd underscore cmd 0x80. 0x80 is given to transfer the data, to write the data on the first line and first column. Okay. So when the CMD is called, it 0x80 will be going to this CMD function and it will be transferred to LCD. When the data function is called, that is LCD underscore data, and here the string h is or the character h is given. Here the character h is given. This h will be transferred to the data function and the data function h will be placed on the data port and then it will be received by the LCD and it will be displayed on the LCD. Like that, in the same way, ELLO will be also displayed on LCD. In the previous slide, a simple and beginner level explanation was given. In this slide, it shows a full real program. Now, you already know that we are interfacing a 16 by 2 LCD with microcontroller in 8-bit mode. So here I'm going to display Welcome to Evolve with scrolling effect. Now let me explain how briefly it works. We first initialize the LCD using the LCD init. This function is used to send important command like setting 8-bit mode, turning on display and positioning the cursor. Next, the function CMD is given. It is used to send command to the LCD. After that, the function given is the data function or the DAT function, which is used to send the character to the LCD. And later the void show is given. That is, the void show means it is a function used for showing or displaying a complete string character by character. After that, we have set the configuration, we have given the configuration bits. After the initialization process, that is, all these things we have said before was the initialization process. And after the initialization process, the message welcome to evolve is displayed on the screen. To make it more attractive, we use the command 0x18 inside the loop, which shifts the display to the left, creating a scrolling effect. Now let's see the interfacing of LCD and microprocessor in Proteus and how it works when the code is uploaded. Okay, so this is the circuit for interfacing 16 by 2 LCD with PIC16F877A in 8-bit mode. Okay, so the components that I have used are PIC16F877A, then the crystal and the capacitors for the crystal oscillator, that is the 22 pico, the capacitor uses 22 picofarad. And the main component is the LCD. The series of the LCD I have used is LM016L. So there are different variant of LCDs in your component list, but you have to take the LCD with the series name LM016L. Okay, and I have connected the RS, RW and enable pin to RC0, RC1 and RC2 respectively, and the data pins of the LCD from D0 to D7 are connected to RB0 to RB7 of port B of the microcontroller. Okay, and now what we are going to do is we are going to load the hex file of the program to this microcontroller. For that, I have already done the program over here. Okay, and also I have already created the hex file. I hope you know how to run the program and how to create the hex file. I'm copying the hex file here and I'm going to paste it in the microcontroller. Okay, by double clicking it here, and here I'm going to paste it. Okay, so I have pasted it and I'm going to click OK. Okay, now what I'm going to do is I'm going to run it, and now you can see the output. So you can see that the LCD is displaying welcome to Evolve Robotics, and it is shifting the display from the displays running from left to right. Okay, so with this, I'm concluding the video. So see you again with another topic. Thank you for watching the video. Bye.